Okay, so this is your Unit 6 review video. We're going to just scroll through so you see which problems I'm going to do. I'm going to do both the piecewise functions on the first page, and then piecewise question on the third page, just different things to ask. I could ask you about average rate of change, find the inverse, some composition work, some domain and range, and verifying inverses, composition work on a graph, and that'll do it. So we'll come back up to the front here. Okay, piecewise function is quite literally pieces of functions. So read from left to right, I'm going to start by being this parabola, then I'm going to be a horizontal line over this interval, and then I'm going to be another line over this specific interval. So I'm going to start with this first function, x plus y, x plus 3, the quantity squared. So what you would do is take a look at your calculator and pull up a table of values. So I've already plugged in x plus 3 squared. Look at my table of values. Now the key is you're going to be this parabola during this interval. So when x is less than -1, you're going to be this parabola. So the key is to look at your table of values and copy down the table when x is less than -2. Now the trickiest part is just remembering what is less than -2. So if you got 0, -1, -2, less than is this way. So you're going to pick values like -3, -4, and so on. So if I pull up a table here, looking at my calculator, I know -2 is at 1, so I'll write that down. And then it looks like I've got -3, 0, -4, 1, and I'll get another one, -5, 4. So we'll write those down. Now, at -2, 1. So at -2, this is just x is less than -2. Because it's just less than, that means it's going to be an open circle. So I'll write a little open circle next to so I know how to graph that. Okay, so as I go, I guess I'll just graph this. I've got -2, 1. It's an open circle. -3, 0. Oops. -4, 1. -5, 4. And I got an arrow because this is going to continue. And it'll look something like that. Okay, next. It seems strange when it just says f of x equals 4, but remember f of x is a fancy way of saying y. This is just y equals 4, which as we know, based on Hoy-Vux, that's just going to be a horizontal line. So during the interval -2 to 2, so that's -2, -1, 0, 1, 2. Those are all the integer values in between. X is going, or y is going to be 4. Okay, now because it's less than or equal to, it'll be a closed circle at that value. So I'll go to -2, 4. Draw a closed circle, closed dot. And then at x equals 2, well, I should say less than 2. When x is less than 2, it's going to be open. So at 2, 4, it shall be open. So everything included, or in between, is just a solid line. Lastly, when f of x is -2x plus 2, on the interval x is greater than or equal to 2, will be that line. Or we will be that line on that interval. So if x is greater than or equal to 2, that means x is 2, 3, 4, 5, and so on. Now let's just say I already plugged these into my calculator, so I know the corresponding value on this function. X would be -2, 3 would be -4, 4 is negative 6, and 5 is negative 8. At x equals 2, though, because it's going to be greater than or equal to, it'll be a closed dot at 2, negative 2. Okay, and then it just extends toward infinity, and you can draw an arrow. So 2, negative 2, closed. Okay, so like that. And that is f of x. So the domain is your x's, range is your y's. If you look at the function from left to right, this function is going to keep extending toward negative infinity. So everything's going to be covered here. There's a hole on the graph here, but it's covered up here. So x equals negative 2 does exist. And same thing here, there's a hole, but then it's covered in this hole. And then as we look toward positive infinity, the function is going to keep extending out that way. So our domain is all reals. Our range has some restrictions though, because you'll notice you've got this huge gap like right in there. So when I'm figuring out my range, I'm thinking, all right, well, how can I break this up? It looks like my range is all the y's that are greater than or equal to 0, because that's the y, or the value of y here on the x-axis. So my range includes 0 to infinity, because again, it's starting from the x-axis and extending up. Then I've got this gap. Then it looks like from negative 2 to negative infinity, or actually you would say that vice versa, is also where our range is. So we would say from negative infinity to inclusively this negative 2, using a hard bracket to include that in my solution, and that's our range. So if I asked you to evaluate f of 50, obviously it's not on this graph, but what you would do is look at 50, that's your x value, and then look at each of these intervals. So I'll erase this for now. 50 is in the interval x is greater than or equal to 2. So because of that, I'm going to plug into negative 2x plus 2. So I'll plug 50 in. So I've got negative 100 plus 2, which is 98. And that would be your answer. Okay, next, tomorrow I could ask you to come up with an equation of a piecewise function. When I'm looking at this, I'm seeing a parabola and a line. But I'll start with the line as I'm going to read it like a story from left to right. Whenever we come up with an equation of a line, we're going to need slope and y-intercept. So if I'm looking at this, I'm noticing my boxes here on my scale. Each box is 1. If I pick a couple points here, I don't know, just pick this point and this point, it looks like I go up 2 and over 1, which I'm actually going to redraw this real quick. This point, up 2 over 1. So that means my slope is a positive 2. Now you can't see it on your grid, but you could continue this up and keep going up 2 over 1, up 2 over 1, up 2 over 1, and that would be at 17. Or you could do an algebraic solution and say, well, I know it's going to be of the form y equals mx plus b. I know that the slope is positive 2. Don't know the y-intercept, and I could just pick a point that would help me solve for what b is. So I don't know, I could use this point negative 5, positive 7. So this gives me 7 is equal to negative 10 plus b. So b is equal to 17. Either way, you get a y-intercept of 17. So the equation of this line is 2x plus 17. So when I write my function, got f of x is equal to, bracket, first function is 2x plus 17. That's my line. Then you got to say, when are you going to be that line? When x is less than, looks like x is equal to negative 3, less than or equal to negative 3, you will end up being that function. And I know it's going to be just less than or equal to negative 3 because I've got this arrow. It's going to keep extending toward negative infinity. Okay, and I know it's less than or equal because of this closed dot. Okay, next we've got this parabola. If you take a look at the points, it goes 1, 1, 2, 4, and 3, 9. So this tells me this is just your basic y equals x squared parabola. So when are you going to be this x squared parabola? It looks like we are going to be this parabola. It looks to be beginning at x equals negative 3, but not including negative 3 because of the open circle, and then extending toward infinity. So when x is just simply greater than negative 3, you will be this parabola that is y equals x squared. Next, just some evaluating using the graph. If you've got a piecewise here, which looks like it's a couple lines, parabola, and I want to find out what f of negative 1 is, you go to x equals negative 1, go up to your graph, and it looks like we're at what 1 would be. Okay, f of 2, go to 2. Notice that there's a hole here. Don't go to this value, go to the value where there is a solid dot. So at x equals 2, y is 4. Now this one is one that stumps people. I want to find x when f of x equals 4. So this is related to the one above it. F of x equals 4 is the same thing as y equals 4. So you would look at the line y equals 4 and see where it crosses the function f of x. It crosses at this corresponding x value of 2. So your answer is x equals 2. Okay, the domain of this function, again looking left and right, those are all your x's. I always like to assess where the holes are to make sure, you know, there is a solid dot at that x value. It looks like we're all good over here on the left because it extends toward infinity or negative infinity. Okay, I got a hole here, but it's okay because I've got a solid dot up here, and then it extends toward infinity. So my domain is all reals. My range, though, I'm just going to clean this up a little bit. My range, if you look from up to down or down to up, it looks like it extends toward negative infinity. Got like a solid horizontal line here, but I don't go up here at all. That's not happening up there. So I only go as high as 4. So I'll write my range as from negative infinity, because it's going to keep going downward, to positive 4, and include positive 4 because that's an open circle. Or sorry, a closed circle, I mean. Okay, given the following quadratic functions, I want to figure out which function has a greater average rate of change over the interval of negative 1 to 1. Average rate of change is just slope. So that's y2 minus y1 over x2 minus x1. Make sure you know this formula. Now, over the interval of negative 1 to 1, on my table for what looks like it's called n of x, here's x equals negative 1, here's x equals 1. So I'll be using those values. For g of x, I'll have to actually evaluate it. So g of negative 1, if I plug it in, is negative 1 squared minus negative 1 plus 6. That's negative 1 plus 1 plus 6, which just then is 6. So our 1 coordinate here is negative 1, 6. G of positive 1 is negative 1 squared minus 1 plus 6. So that's negative 1 minus 1 plus 6. So that's negative 2 plus 6, which is 4. So our other coordinate is then 1, 4. So if I do slope with these points, I'll do 6 minus 4, so change in y, over negative 1 minus 1, change in x. And I'm doing it in the same corresponding order. 6 corresponds with negative 1, 4 corresponds with 1. So I get 2 over negative 2, which simplifies to negative 1. So that's our average rate of change of g of x. Now I'm going to do my table n of x. So for n of x, our coordinates were 1, 9, and negative 1, 5. So 9 minus 5 for change in y, over 1 minus negative 1 for change in x. I get 4 over 2, which is then 2. So which function has the greater average rate of change? N of x does. All right, and number 5, we are given m of x and we want to find m inverse of x. First thing I'm going to do is rewrite m of x as y equals x minus 3 over x. Now when I find the inverse, it's always about switching x and y. So I'm going to change x and y here. And then I'm solving for y. So I'll put x over 1, and then I'll cross multiply. So I get xy is equal to 1 times y minus 3, or just y minus 3. Now the key is to get the y's together. So I'll subtract y from both sides. So I get xy minus y equals negative 3. And then I'll factor out the GCF of y, because then that will give me 1y. Now that I have 1y, I can divide both sides by x minus 1, and then I would have solved for y. But my answer is not going to be y equals, it's going to be m inverse of x. So final answer, m inverse of x is equal to negative 3 over x minus 1. And we would have found the inverse. Okay, for number 7 here, these are just operations on functions. So just quickly telling you what each of these mean. P plus h of 3 is just you evaluating p at 3, evaluating h at 3, and adding it. Same thing with subtraction. Make sure you're doing it in the order it's given, though, with subtraction, because it's not commutative. The solid dot is multiplication, so p of negative 4 times h of negative 4. And lastly, f divided by p, both of 7. The open dot is called a composition, and it has to be read from right to left. So the way you do this is you start with h, and you evaluate h at 2. So h is this function, x squared plus 4. So I'll do 2 squared plus 4. So that's 4 plus 4, which is 8. Now that result is going to end up going into our p function. So I'll evaluate p at 8. P is x plus 2, so I'll do 8 plus 2, and that gives me 10. So again, I'm just referring to the functions h and p here. I did h first, then p. Okay, in this composition, I'm going to take the p function and plug it into the g function. And I'll actually rewrite this in nested notation just so it makes it a little bit more obvious what I'm doing. So I'll start by saying the g function is 16, so this is g of x. 16 minus x squared. Now where you see an x, I'm going to plug in the p function. So I have 16 minus, there's an x, so I'm going to plug in p, which is the square root of x plus 4. And that entire thing will be squared. So when I simplify this, I have 16 minus square root and the square will undo the square root, so 16 minus the quantity x plus 4, so that's 16 minus x minus 4 by distributing that negative. So in the end, I have negative x plus 12. Okay, now f times g of x, I'll just write f of x is equal to x plus 3 over x minus 4. G of x is 16 minus x squared, and I'll multiply this. So I'll put this over 1, and when I'm multiplying rational expressions, remember that it will be helpful to factor anything I can, which this is dots. So I've got x plus 3 over x minus 4 times 4 minus x times 4 plus x. And I see right here I can cancel x minus 4 with 4 minus x, but it cancels to a negative. So my final answer is the negative x plus 3 times 4 plus x, which if it wants me to put this in standard form, it's negative. I actually rearranged the 4 plus x to be x plus 4 to help me FOIL. X squared, inner and outers give me 7x. My lasts give me 12. So then distribute the negative, negative x squared minus 7x minus 12. So what is the domain of B? Well, if you think about the domain of the originals, if you look at F, the only restriction on your domain is that x cannot equal 4, because that would cause the denominator to become a 0, and then the function would be undefined. G of x is just a parabola that's been reflected in the x-axis and shifted up 16 units. So it looks something like that. The domain on that function is all reals. But when we multiply, we have to take on the restriction of, well, either of them. G of x has no restrictions, but f of x does. Therefore, the domain is going to be all reals, but x cannot equal 4. Again, because that was a restriction on the original function f. All right, if I'm going to verify that functions are inverses, I'm going to compose two functions together, and I should get x back. Now, in the example that I'm going to do, I'm hoping to get n. And you just got to imagine that's because these are all now in terms of n as opposed to x. It's the same thing, okay? So again, if you do f of g of x, you get x, and you do g of f of x, and you get x, then they're inverses. But in this case, I'm going to do n because that's what the function is in terms of. So first thing I'll do is f of g of n. So I'm going to take the f function, and where I see an n, I'm going to plug in my g function. So I've got negative 16 plus 4n plus 16 all over 4. And there's my substitution. Now I just got to clean it up. Negative 16 and 6, or sorry, negative 16 and 16 will go to 0, so those cancel. So I get 4n over 4, which the 4's will then reduce. So we get n. But once I get it one way, I still got to check the other way. So I'm going to do g of f of n. So I'll take my g function, and where I see n, I'm going to plug in my f function. Oops. So I've got 4 times, now n is going to be negative 16, I'll do this in red, plus n all over 4. And then that'll be plus 16 too to finish out my g function. Okay, so now I've just got to reduce. My 4's will cancel. So I have negative 16 plus n plus 16. 16 and negative 16 go to 0, and I get n. So since I got n in both directions, f of n and g of n are inverses. All right, and then I think this is the last thing I said I would do. Yep, last thing I said I was going to do is just compositions based on some graphs here. So if I want you to do g of f of 3, the first thing you're going to do is f of 3. So I'm going to go to x equals 3 on my graph and make sure I go to the f function. And it looks like the corresponding y value I get is 2. So then we're going to do g of 2. So I'll go to x equals 2 on my graph, go up to my g function, and I come out at y equals 5. So that's my answer. Now, if it's written in composition notation like this, so this is nested, this is composition, again, you're reading from right to left. So the first thing you'll do is g of negative 1. So I'll go to x equals negative 1, go to my g function, which it looks like I come out at y equals 5. Then I'll go into my f function. What is f of 5? Go to x equals 5, go to my f function, and I come out at y equals 4. So that's my final answer. Now, one more thing before I turn this off is just note how number 10 is worded. If I give you the inverse and I want the original, it's the same thing that we did up above. Where was it? Up above here in problem 5. You just rewrite the inverse as y, switch x and y, and then your final answer wouldn't be an inverse, it would be the original. So what I mean is the answer that you would end up having isn't g inverse of x because they gave you g inverse. Your answer would be g of x equals. So it's the same process. Okay? Good luck.